In this video, I will explain you how to solve this example for RAM and ROM interfacing. So in this example, what is given? Design 8086 microprocessor-based system with the following configuration or specification. The first concept is our 8086 processor is working at 10 MHz in minimum mode. The second point is it consists of 64 KB of EPROM and 32 KB of SRAM. So based on that given data, first of all, we will find out how many address lines will be required and what is the IC number for each and every ROM and RAM will be given in the example. So here in this example, the first statement is given, that is 8086 is working in minimum mode. So I can write here the first statement, that is 8086 microprocessor is working in minimum mode. So whenever it is working in minimum mode, that time we are connecting this minimum and maximum bar pin is connected to the VCC. Now we have two types of memory bank will be available in our 8086 processor. The first one is even memory bank and the second one is odd memory bank. So these two types of bank will be available in our 8086 processor. So whenever we are writing here the even memory bank, then we have to remember that this even memory bank will be connected to our A0 line of our address bus. And whenever we are writing here the odd memory bank, so this bank will be connected to the bus high enable signal of our 8086 microprocessor. So now we have solved with the first statement, that is 8086 is working at 10 megahertz and the minimum mode will be working in that processor. So you can skip this part, that is 10 megahertz. So in the features we have already learned this 8086 processor is working at 8 megahertz, then 10 megahertz. So that in the given example it is given, that is our processor is working at 10 megahertz. But for solving the example, you can skip this part. You have to check which mode of operation will be given in the example. So either it is minimum mode is given or maximum mode is given. But in this example, the mode is given, that is minimum mode. So whenever your processor is working at minimum mode, that time this data will be connected to the VCC. And there are two types of bank will be available, that is even memory bank and the odd memory bank. Whenever your processor is working at even memory bank, then it is connected to the A0 line of our address bus. And when it is connected to the odd memory bank, then it is connected to the bus high enable signal. Now we will move to the second part of our data. So in the second part, what is given in that example, the data will be given as there is 64 KB of EPROM will be available. So this is called as a 64 KB of EPROM. So here we have two types of memory banks will be available. So whenever we are dividing this 64 KB into two parts, then we can write it as 32 KB and 32 KB. So here there are two types of memory bank will be created out of that 64 KB, and we are writing here 32 KB of data will be available, and these two data will be considered as a even and odd memory location. So 132 KB will be considered as an even memory location, and the second part of our 32 KB will be considered for our odd memory location. And whenever it is connected to the even and odd memory location, then even memory bank will be connected to the A0 line of our data, and our odd memory bank will be connected to the bus high signal to the data lines. So here the bus high signal will be activated. So there are two types of memory bank will be available, even and odd. and our A0 line is connected to our even memory bank, and our odd memory bank will be connected to the burst high enable signal of our memory bank. So now we have divided our 64 KB of EPROM into two blocks, that is 32 KB and 32 KB. Now we have to calculate how many address lines will be required for connection of this 8086 microprocessor. So here I am calculating the address lines that is required for our EPROM. So how we can calculate the address line? For example, 1 kilobyte is equal to 1024 memory locations. And here in our even and odd memory bank, we have 32 KB of data will be available. So 32 KB is nothing but 32 into 1024 location. So whenever I am considering here 32 KB, so I am writing here instead of 32, I will write here 2 raised to 5 into for 1024, I am writing here 2 raised to 10. So 2 raised to 5 and 2 raised to 10, it is nothing but 2 raised to 15. So we got this number as a 15. So here in this case, we require 15 address lines will be there. So here you can write 2 raised to 15, we got the answer. So 15 address lines will be required for our EPROM. So now we have to identify which address lines will be connected to our 8086 microprocessor. So in this example, you can see we have connected this A0 line to the even memory bank. And here we require total 15 address line. So how we can write the address line number for this given data? We can write here we will require the line number A1 to line number A15. These address lines we are considering in our EPROM. Now we have to find out the IC number for our EPROM. So how we can calculate this IC number? So we have to write down here IC number is equal to 32 KB because we got even and odd memory location, that is 32 KB of each. So here 32 KB into 8 bit. So why here we are considering this 8 bit? Always we have to consider this 8 bit because our input output operations will be considered as the 8 bit of operations, and that devices are connected to the 8086 microprocessor. So there is 16 bit of data will be available, and out of that we are using the 8 bit of data for our input output port. So I am writing here 32 KB into 8 bit, and we will got here the number that is 256. So we got the answer 256. So I'm writing here IC number is equal to 27256. So 27 is the prefix for our EPROM, and 256 is the value that we got from this IC number that we have calculated, that is 32 KB into 8 bit. So first of all, you have to write down the prefix for your EPROM, that is 27, and then we are writing here 256 that we got the number from our calculation. So currently we have completed with our second part of our data, and in that we have calculated how many address lines will be required and this line number that we are considering for the address line and this IC number. Now the same procedure we have to follow for our 32 KB SRAM. So I'm writing here 32 KB SRAM. So whenever you are considering this 32 KB SRAM, that time we will consider here the 16 KB and 16 KB for each and every even and odd memory bank. So I'm writing here 16 KB, and here also you can consider the 16 KB. So the same concept we are following, that is for even and the odd memory bank. So the 16 KB data will be given for the even memory bank and the 16 KB data for given for the odd memory bank. Whenever it is connected to the even memory bank, that time we are using this address 0 line for connecting our lines. And for the odd memory bank, we are connecting here the bus high enable signal. So now we have to calculate how many address lines will be required for each and every RAM. So I'm writing here address lines require is equal to 16 KB, and we already know 1024 memory locations will be required for each and every 1 KB. So 1 KB is equal to 1024 memory locations. So I'm writing here 16 KB is equal to 16 into 1024. So 16 is nothing but 2 raised to 4, and 1024 is equal to 2 raised to 10. So 2 raised to 4 into 2 raised to 10. So we can write here 2 raised to 14. So here we got the number 2 raised to 14. So 14 address lines will be required in this example. So I'm writing here 14 address lines required for our SRAM. So I'm writing here the address line number, that is address lines will be considered as A1 to A14, because A0 is the address line that we have already used for the even memory bank. So we have to consider the address lines from A1 to A14. Here we have completed with our address line calculation. Now we have to calculate what is the IC number for our SRAM. So how we are calculating the IC number? First of all, we have to take here the 16 KB of our data into 8 bit of our input output port data. So 16 KB into 8 bit is equal to, we got the number that is 128. So 128 is the number that we got from our calculation, and here I am writing the IC number, that is 62, and then I am writing here 128. So 62 is the prefix that we are using for the SRAM, and 128 is the number that we got from our calculation. So now currently we got the IC number for our SRAM, and also we got the IC number for our EPROM. So currently we have done with the calculation part of our address line, then which mode will be available, then what is the IC number for required for our RAM as well as our ROM. Now we have to draw the memory interfacing diagram. So here there are two memory banks will be available, the odd and the even memory bank, for EPROM also and for the SRAM also. So now here we have extended this first high enable signal as well as our address line signal, then our D0 to D15, that is our data bus, and the memory read and the memory write signal. So these 5 lines are extended from this minimum mode configuration of our 8086 processor. So now how we are doing the interfacing with the help of this EPROM and SRAM. First of all, we have to draw the read signal. So how we can draw the read signal? So this read signal is available for our EPROM for odd also and even also. So I'm writing here this, and I'm connecting this memory read signal with our EPROM odd bank and EPROM even bank. Now for SRAM, both the signals will be activated, that is read signal also and write signal also. So I'm giving this read connection here and I'm giving this write connection here. So read and write connection is connected to our SRAM odd bank. As well as for our SRAM even bank, we are also giving this read connection as well as this write connection. And now here you have to write whatever the connection you are giving to our memory banking, that I am writing here, that is read bar, and here also I am writing read bar. Then here I am writing read bar as well as WR bar. This is also read bar and WR bar. So currently we have completed with our read bar and write bar signal. Now the next one is we have to draw this data bus for our EPROM as well as our SRAM. So whenever you have to draw this data bus for our even banking and odd banking, then the first point we have to remember that for even banking, we are giving this D0 to D7 line. And for odd banking, we are giving this D8 to D15 line. Total, we have 16 bit of data bus. And out of that 16 bus, the 8 bit will be assigned to our even memory banking and 8 bit will be assigned to our odd memory banking. So this is our data bus and I'm connecting here this line for our data bus signal. So I'm drawing this data bus and this is the bi-directional data bus. So I'm giving this type of connection to our data bus. The first connection is given, then the second connection is given. And this is called as a bidirectional data bus. So here in case of EPROM, for the odd, I have to write here D8 to D15 signal. And for the even connection, I am writing D0 to D7 signal. So now we have done with our EPROM for data bus. Now we have to draw this data bus for our SRAM. So for SRAM also, I am giving the same connection, that is D8 to D15 for our odd memory banking and D7, D0 to D7 for our even memory banking. So we have give the name to our odd and even memory bank for our data bus. So here I am writing D8 to D15 and here I have to write D0 to D7. So now we have done with our data bus and then the last one we have to draw the address bus for our EPROM as well as SRAM. So first of all, I'm writing this connection here and I'm giving this single directional bus, that is a unidirectional bus. So all the lines will be connected first. So here I have connected this all address bus to our EPROM as well as SRAM. This connection starts from this address bus line. So now I have to give the name for that address line signal. So in case of EPROM, we got 15 address lines. So I'm writing here A1 to A15. Here also I'm writing A1 to A15. And for the SRAM, we got total 14 address line. So I'm writing here A1 to A14. Here also I can write the A1 to A14. And these connections are given for our odd memory bank as well as our even memory bank. So now we have done with our diagram, that in that diagram we have connected this read signal for our EPROM, read and write signal for our SRAM, the data bus, that is for even memory bank we have connected this D0 to D7 line, and for the odd memory bank we have connected this D8 to D15 line. For the address bus, whatever the address bus we have calculated, that we have written here, that is for A1 to A15 signals are there for EPROM and A1 to A14 signals are available for our SRAM. Now we have to write the IC number for our EPROM as well as SRAM that we have already calculated. So what is the IC number for our EPROM? That is 27256. So I'm writing here 27256 for our EPROM. The same IC number I'm writing here on the odd memory bank location, and then we have to write the IC number for our SRAM. So the IC number for our SRAM is 62128. So you can write here 62128, as well as you can write here 62128. So you have written here the IC number for each odd and even memory bank location. So in this way, you can solve this problem in the example. So whenever the question can be asked in the exam, that time, first of all, you have to check the which minimum mode will be given. Either it is a maximum mode or minimum mode. Then we have to calculate the size of the address lines, number of lines will be required for our address line, for our EPROM, as well as our SRAM. Then the third thing will be we have to calculate the IC number for each EPROM and our SRAM. And based on that information we got, that is number of address line and the IC number, we have to draw this memory interfacing diagram. And with the help of this EPROM and SRAM, we are doing the interfacing with our 8086 processor in minimum mode configuration. So this part of our diagram is given for our minimum mode configuration. And we are connecting this EPROM and our SRAM, that is our ROM and RAM structure, with the help of interfacing of our pin number, that is memory read signal and memory write signal. So with the help of this control bus, we are connecting this EPROM and our SRAM to our 8086 CPU in minimum mode configuration.